Hello friends, again I came back to you. Today we are going to discuss now valency. In our previous concepts we have discussed about electronic configuration, how to write the electronic configuration, and s orbitals and p orbitals, how they are involving in the to form like electronic configuration, that and all we have discussed, right? So now a new concept now. This is actually very small concept, especially for small kids, they easily can remember the chemistry here. So valency. What is meant by valency? Combining capacity of an element. Combining capacity. For example, see here, this marker is there. I am doing just how I am doing. I am using something, some capacity I am giving here, like force. Okay. So this is normally in the case of pen I said. But in case of like elements, how can we say? By attracting. Okay. By combining. One element is combining with another one, forming capacity of that particular element only we are saying as a combining capacity of an element. So now here I wrote the definition, and here see A atom is there. This A atom is combining with the B and forming as a AB product, right? So this is what we can say the matter formation. This is according to the olden definitions. And now when you are coming to the new like day by day years is passing now. So new concept, what we can say, addition of one hydrogen atom or addition of one chlorine atom or double the number of oxygen atoms. Okay. So what is it means? I will tell you here. For example, sodium atom you take, symbol of sodium is Na plus hydrogen when you are taking. So it is forming as a NaH. Okay. So now one hydrogen atom, right? You take the same thing as a chlorine atom. Na plus Cl gives NaCl, right? So one chlorine atom and one sodium atom, both are combining each other, forming a compound. Next, again sodium atom only I am taking. Oxygen, what we wrote here, double the number of oxygen atoms. So here we can say Na plus O2 gives Na2O. Balancing we are writing here, so 2Na. Okay, so double the number of oxygen atoms. In the sense, two sodium atoms are sharing one oxygen. That is why we are writing like this. And even next, another definition we can say gaining of electrons or losing of electrons, or even sharing of electrons also we can say. Sharing of electrons. This also we can say it as a valency. Okay. So I hope understood everyone. So now how can you find out the valency of metals and non-metals? So now you see here I am writing here as a valency of metals. Valency of metals. Usually metal atoms. Total in the periodic table 92 metals are there, right? So in the when you are considering the metal atoms will have 1, 2 or 3 valence electrons in the valency shells. Valence electrons will be there. Okay. So for example, common example I will take here, sodium will take. Atomic number of sodium 11. I will write the configuration 1s2, 2s2, 2p6 and 3s1. Okay. So this is what I am writing as a 2, 8, 1. Right. So first shell, second shell and the third shell. Which is the valency shell here? The third shell is the valency shell. And this is valence electron. Right. This is valence electron. Okay. So 2, 8, 1. So this is a valence electron. And the remaining 2 plus 8 we can say it as a core shell electrons, means core electrons, right? The same thing. Another example I will give you. Like we will take magnesium. After the sodium, we will take magnesium. Atomic number of magnesium 12, 1s2, 2s2, 2p6 and the next one more electron is increasing, right? So 3s2. So first shell, second shell, third one. Same thing we are writing here, which is the valency shell 2, 8, 2, right? So number of valence electrons here 2. So then magnesium valency is equal to 2. Magnesium valency is equal to 2. Next you take aluminum, 13th element. Next only no, just successor. So we'll take here 1s2, 2s2, 2p6, 3s2, 3p1. So now here again valency shell 2, 8, 3. Why 3 I wrote here? Here you will get confusion. Because s orbital's capacity is 2 electrons. And when it is coming to the next p orbital, one more electron is coming here, right? So 2 plus 1, how many electrons? 3. That is why I wrote here 3. Then what is the valency of aluminium? 3. So you take any metal atom, all the D block elements, even S block elements 1 and 2, like 1A and 2A groups, almost metals will have 1, 2 or 3 valence electrons always. Okay. So now I hope everyone knows about this. What is the valency of metals? 1, 2 or 3 valence electrons will be there in the metal atoms. Next, when you are coming to the non-metallic elements. What about the non-metallic elements? This only you should remember more. Okay. So I will show you how to remember that non-metallic elements. Non-metallic elements usually, can you tell me any one example? Like carbon, hydrogen, chlorine. We are taking like nitrogen, oxygen, even phosphorus, sulfur. All the non-metals are available in the form of solids and liquids and even gases also. Liquid non-metal only one, that is a bromine. Right? So here non-metallic elements. Valency of non-metals. Valency of non-metals. So you take here non-metals. For example, periods I am taking here, you see, like carbon, nitrogen, oxygen, fluorine I am taking. Okay. Carbon, nitrogen, oxygen, fluorine. This is in the second period elements. So now you take here carbon. Carbon atomic number 6, right? So 6 means carbon, atomic number 6, atomic mass 12. So I am writing configuration 1s2, 2s2, 2p2. Total 6 electrons are there, right? So we can write here K shell, L shell, valence electrons 2, 4, right? Next, when you take nitrogen, we are saying here N7, 14. So 1s2, 2s2, 2p3. So number of valence electrons will be 5. Okay. So here number of valence electrons in carbon, we can say valence electrons is equal to 4, right? In case of nitrogen, number of valence electrons 5. Okay, 5. And then the same thing, oxygen you take. 8, 16 we are taking. 1s2, 2s2, 2p4. So 2, 6 we can say. So means number of valence electrons is equal to, I am writing it as VE 6. Right? No. So everywhere 6. But when you are considering to the metals, 1, 2 or 3 we are saying, right? So here 4, 5, 6 it is coming. Then how can you find out the valency? Number of completely filled electrons, or we can say octet electrons. Number of completely filled configuration, we are saying 8 electrons. Okay. Because NS2, NP6 is the configuration of 8th A group elements. So now 8 minus number of valence electrons is equal to group number. So 8 minus 4 is equal to 4. 8 minus 5 is equal to 3. Next 8 minus 6 is equal to 2. 8 minus 7 is equal to 1. 8 minus 8 is equal to 0. Right? So like this you have to remember. And then when it is coming to the carbon you take. Combining capacity we said no. So carbon valency 4 we said 4. So carbon can have the capacity to form a bond with 4 hydrogens of carbon. So example we can say methane molecule. This CH4 means we are calling it as a methane. And nitrogen you take. Nitrogen valency, what I said here, 5 valence electrons are there. This is for carbon, nitrogen, this is oxygen and this is fluorine. And the 8th one, this is noble gases. We can say for this noble gases, because noble gases are having completely filled configuration. That is the reason they are not ready to interact with any other elements, because combining capacity will be 0 in case of noble gases. Why? Completely filled configuration. Okay. So now ammonia I am taking, NH3. Name of this compound we are calling as ammonia. Okay. Ammonia. So like this we can take. Even like any elements you can take, all the elements like non-metallic elements. Even you take a chlorine. Chlorine valency. Chlorine belongs to 7th A group elements. So chlorine valency, when you are considering even normal electronic configuration, I will show here. So 1s2, 2s2, 2p6, 3s2, 3p5. Okay. So First shell, second shell, third shell. So 2 comma 8 comma 7 electrons. So here 7 valence electrons are there. 7 valence electrons. But when we are considering about the valency, we have to do 8 minus group number. That means 8 minus 7 is equal to 1 valency. So now chlorine valency will be 1. Okay, chlorine valency will be 1. So once again I am repeating the children, non-metals always will have 4, 5, 6 or 7 valence electrons in their valency shells. Okay, so that 4, 5, 6 or 7 valence electrons only we are going to find about the valency of the non-metallic elements. See now here, descending order is coming 4, 3, 2, 1, 0. But in case of metals, ascending order 1, 2, 3, 4 like that. 4 is not there usually, 1, 2, 3 only will say. So 1, 2, 3, after that 4, 3, 2, 1, 0. Okay, so descending order. So like this easily you can able to remember the valency concept. I hope everyone understood about this. Please like, share and subscribe my channel. Thank you all.